Computing the mean, variance, and standard deviation of a probability distribution. In this lesson, you will learn how to compute and interpret the mean and variance of discrete probability distribution. So let's begin with the formula for mean of probability distribution. The mean of random variable with a discrete probability distribution is obtained by using this process. So this symbol stands for the mean, or we call this as mu. So in order for us to get the mean of the probability distribution, we'll need to get the summation of the product of your variable and their corresponding probability distribution. So for example, here we have your x sub 1 times the probability of your x sub 1 plus the product of x sub 2 and the probability of your x sub 2 plus x sub 3 times the probability of your x sub 3. And then you will follow this process up until the last variable on your probability distribution. Or we can say that your mean is equal to the summation of the product of your random variable x and their corresponding probability distribution. Okay, so once again, your x sub 1, x sub 2, x sub 3 up until x sub n are the values of the random variable x. And your p, or probability of x sub 1, probability of x sub 2, probability of x sub 3 up until the last probability are the corresponding probabilities of your distribution. So let's try to do this activity in finding the mean for grocery items. So the probabilities that a customer will buy 1, 2, 3, 4, or 5 items in a grocery store are 3 over 10, 1 over 10, 1 over 10, 2 over 10, and 3 over 10 respectively. What is the average number of items that a customer will buy? So to solve for the mean, let's follow the steps. So the first step is to construct the probability distribution for the random variable x, representing the number of the items that a customer will buy. Okay, so from the given problem, we have number of items, which are 1, 2, 3, 4, and 5. So the probability of each variable is also stated from the problem. So the probability of 1 is equal to 3 over 10. The probability of 2 is 1 over 10. The probability of 3 is 1 over 10. 4 is 2 over 10. And the last number of items is, or has, the probability of 3 over 10. Next step is to multiply the value of the random variable x by the corresponding probability. Okay, so we will do it horizontally. So first, let's multiply 1 and 3 over 10. So the product is equal to 3 tenths. Next, we multiply 2 and 1 over 10. You can grab your calculator with you so that you can check if our procedure is correct. So that is equal to 2 over 10. Okay, please take note that you don't need to simplify this for the reason that it is easier for us to sum it all later when the denominators are the same. Okay, so the next is we multiply 3 and 1 over 10, so that is equal to 3 tenths. And then for number of items, which is equal to 4, and its corresponding probability, their product is 8 over 10, and for the last one, we have 15 over 10. Okay, so for the third step, we add the results of the process that we obtained in the second step. Okay, so just add it all from our last column, and their sum will be equal to 3.1 in decimal number. Okay, so the sum is their mean. Okay, so the mean of the probability distribution is equal to 3.1. This implies that the average number of items that customer will buy is 3.1. So this is how we interpret the mean from the problem that we have. So the mean is the average number of items that a customer will buy. So the average number of items that a customer will buy is 3.1. Although an item will never show a number which is 3.1 because we count the number of items as a whole product. So that's why it becomes a discrete variable. So this only implies that the theoretical mean would be 3.1. So it is just giving you the idea that most probably the average number of items that a customer will buy is more likely to be at 3 items. Now let's talk about variance and standard deviation. So let's begin with the definition of the variance. In statistics, variance is defined as the measure of variability that represents how far members of group are spread out. It finds out the average degree to which each observation varies from the mean. When the variance of a dataset is small, it shows the closeness of the data points to the mean, whereas a greater value of variance represents that the observations are very dispersed around the arithmetic mean and from each other. Okay, so next, let's proceed with the definition of your standard deviation. So it is a measure that quantifies the amount of dispersion of the observation in the dataset. The low standard deviation is an indicator of the closeness of the scores to the arithmetic mean, and a high standard deviation represents the scores are dispersed over a higher range of values. So later on, you will take closer look at these two terms right here with our succeeding slides and examples. So let me just present to you first the table for comparison. So again, let's summarize the meaning of the two. So for variance, it is the numerical value that describes the variability of observation from its arithmetic mean. Okay, so let me just highlight to you the term variability of observation. So it means how spread or how far the members of the groups within the observation. And for the standard deviation, it is the measure of dispersion of observations within the dataset. So for the meantime, I know that you are having a kind of um, thinking that variance and standard deviation is sort of the same meaning, but let's discuss further what is it all about so you can distinguish the difference between the two. So what it is, your variance is the average square deviation, and your standard deviation is the root mean square deviation. So it is labeled as, for variance, sigma squared, and for standard deviation, sigma only. It is expressed in squared units for the variance, and for standard deviation, it is expressed as the same units as the values in the data of in the set of data. And how or what each indicates. So your variance indicates how far individuals in a group are spread out. And for the standard deviation, it tells how much observations of a data set differs from its mean. So basically, your variance is the general information that describes the spread out of the members of the dataset. And for the standard deviation, it is the specific range of values from mean to the other scores in your dataset. Okay, so take a look at the steps in finding the variance and standard deviation. So the first one is we need to get the mean of the probability distribution, which we have discussed already. And second, multiply the square of the values of the random variable x by its corresponding probability. And then for for the third step, we need to get the sum of what we have obtained in the step 2. Okay, so here is the finale, how to solve for the variance. So we need to subtract the mean from the results that we obtained in step number 3. So we will be using this formula. So the variance is the summation of x squared times p of x minus mean squared. And this step is on how do we get the standard deviation. So first we need to get the square root of the value that we obtained in step number 4. Or we can just make use of this formula. So to solve for standard deviation, we need to get the square root of the summation of your x squared times p of x minus mean squared. Or in the other words, you just need to get the square root of your variance. So let's make use of the previous problem wherein our discrete random variable is the number of items that we got from the grocery store. So we are done with getting the probability distribution and the mean of this course of this problem. So let's just take note of this one. Okay, so our main focus right now is the last column wherein we will be going to get the x squared times the probability of x. Okay, so to do that, let's just rewrite each value so we are going to be guided. So your x here is the number of items. So in the first row, we have 1. So from the formula here, we need to get the square of 1, and then we will multiply it to the probability na column. So the involved sa sininga process is the column for the number of items and the column for the probability distribution. Let's just disregard the column for the mean. Okay, so to solve, we just we need to multiply the two numbers. So we have 1 squared times 3 over 10 is equal to 3 tenths. And following the same process, we have 2 squared times 1 over 10 is 4 tenths. Next, we have 3. 3 squared times 1 over 10 is equal to 9 tenths. And 4 squared times 2 over 10 is equal to 32 over 10. And lastly, we have 5 squared times 3 over 10. And that is 75 over 10. So again, notice that I haven't get the simplified form for each of the products because as I have said, it will be easier for us later on to add everything if the denominators are the same. Okay, so next procedure for it is to get the sum of your x squared times p of x. So again, following the same procedure, just like what we did in the mean, we are going to add all of this. So the answer will be, or the sum will be 12.3. Again, so the total for the probability distribution is 1. The total value here, which is the mean, is 3.1. And the total value for the initial step in here in order for us to solve for variance and standard deviation is 12.3. So this is not yet the value of our variance. Okay, so we need to apply the formula in getting the variance. So to solve for variance, we will be using this formula. We have the sigma squared equals the summation of x squared times p of x minus your minus the squared of our mean. Okay, so to solve, just substitute the values that we have from the table. So the summation of your x squared times p of x is equal to 12.3. And the value of your mean is 3.1. So just copy the square on top of it. Okay, and now we are ready to solve. So use your calculator to solve this and get their difference. And the answer will be 2.69. So it is exactly 2.69. So therefore, our variance is equal to 2.69. Okay, so let's move on to the last step, which is in solving for your standard deviation. We will be using this formula. We'll just get the square root of our variance. Okay, so again, we substitute the values that we have from the given table. So once again, the summation of x squared times p of x is 12.3, and then we subtract it from the square root of our mean. Okay, so it's such that we get its corresponding square root. So the value will be 1.64012147, or it's approximately 1.64. Okay, so let's discuss what this interprets, or what the values um, means for us. So to better interpret how far members of the group are spread out, we will be getting the coefficient of variation. So to solve, just divide the standard deviation 1.64 and the mean, which is 3.1. In this case, the coefficient of variation is equal to 0.53. So distributions with a coefficient of variation to be less than 1 are low variance, whereas those with coefficient of variation that is higher than 1 are high variance. So therefore, we can say that the value of the dataset is close to the mean, and the distance from the scores and the distance of the scores from the mean is 1.64. Okay, so it is close because we got the coefficient variation that is less than 1. So we get 0.53. It means that we have a low variance. So meaning to say the members of the scores from our data is not that really spread out. Okay, so that ends our lesson number 3. I hope you have learned something from this video. Okay, thank you so much everyone for watching.